Hello everyone, this is Semagan Ateva again, a second year student at Makerere University pursuing a bachelor's degree in software engineering. And I've come again to talk about the laptop price predictor model in AI, and this is going to be the third time. But before I start up, I kindly request for more of your subscriptions and views and likes. As you all know, this is a new channel, and I thank all those that have managed to subscribe and like the videos. I really appreciate the support you guys are giving, and I won't do anything to disappoint you. As I start, I'll start with a recap of the real life problem to be addressed by the LPP system or the model. This project aims at solving the challenges people face in finding the exact kind of laptops they need to solve their everyday problems in work, studies, leisure time, like the games, graphics duties, and many more. This brings about a lot of opportunities for frauds and other people with negative intentions to take this as opportunity to overcharge many different people such that they give them what they want. So this laptop model or the LPP model has come to solve this issue of frauds tending to overcharge people on the different kinds of laptops they use. Because someone takes this as an advantage to overcharge a client or a user of a laptop due to the ignorance of that user. So what this model is going to do is going to prompt the user to insert or feed in the details of the specific laptop he or she needs for his work and any other task, and then it will give back the estimate or the price estimate of that exact laptop, so that this preventing those frauds from overcharging these people. As I go further, we have the AI environment for the LPP model. The environment is the surrounding of the agent in artificial intelligence from which it receives an input and then acts upon that input. So the environment is like in AI we have what we call the environment and the agent. And the agent, I'm going to talk about the agent in the next slide, but a brief recap of a brief preview of the agent. This is like something that perceives or acts something in the AI environment, and the environment is the surrounding of this agent. And the LPP uses different types of environments shown below. We have two environments that can adopt to this LPP model. First one is what we call the deterministic environment. And in this environment, an agent's current state and selected action can completely determine the next state of the environment. So what does this mean? That when a user inserts in like an i5 in the model, um, the the model will be able to predict or to know or determine what's the next stage of the laptop price model and how that laptop would be looking, the price, what, and many more. And the sequential part says an agent requires memory of the past actions to determine the next best action. So it requires memory of the past actions to determine the next best actions. So it's like what we could say it's kind of similar to the what we call the supervised learning technique in AI, machine learning. So it requires memory of memory that helps it to adopt to what the user currently needs at that exact time. And we have agents. As said, agent is anything that makes decisions such as person, farm, machine, or software. It is anything that makes decision in an AI system, in an AI model, or in an um in this LPP case, we are looking more to it as machine and basically software. These AI agents perceive information through the sensors and give back or output using the actuators. For this laptop price predictor test, the sensor includes the keyboard because it's what we use to pass for the environment, like for the agent passive information, it's like the input. The keyboard is the input, and then it outputs through the screen. It gives back an output through the screen. When the user like when it displays that price, that's an output of this model. And the type of agent for the model includes the utility, based agent, and this is used when there are multiple possible alternatives and then decide which is best. So there are multiple alternatives, but then depending on what the user wants specifically, the model gives him back that exact price estimate of that laptop. So it chooses what's best out of the many alternatives of the laptops that are in the model system or model. And then a clear data set description for this LPP. We have the data set to be used in the project has many different details from which output is got after the user inputs the details of that exact laptop he or she wants. We have the company. This is got from the data set I'm going to use. The company, which is a string. We have, and this is the laptop manufacturer, like the Dell, Lenovo, HP, what. And then we have the product. Product is also a string or brand. And then we have the model, like the TN model is also string because it's they have the Inspiron, the Elite books, the Pro books, what, and then we have the type, which is like the notebook, ultrabook, that's also a string. We have the resolution that is numeric, because it's in size, it's in numbers, 13.3, 15.6. We have the CPU, central processing unit. We have the RAM, which is also string. We have the memory, and we have the SSD, what. We have the GPU, that's also a string. We have the operating system, like Windows 10, Windows 11, Windows 7, that's also a string. And we have the weight, which is also a string. At like 4 kilograms, 2 kilograms, and many more. When you go to informed search application to the laptop price predictor, the informed search algorithm uses domain knowledge, uses like known knowledge as they are informed. Under this search, problem information is already available which can guide the search. Here, the algorithm have information on the goal state, which helps in more efficient searching. They have already idea on the goal state, on the target, which helps in more efficient searching. And the LP model uses what we call the A-star search algorithm, which is one of the types of informed search. And this works in a way that the user inserts details of the laptop he or she needs, and then the model searches through using this algorithm and gives back the estimated price of the laptop closest to that as the output. Have the uninformed search application to the laptop price predictor, and under this algorithm, the search algorithm have no additional, they are just there, have no additional information on the goal node other than the one provided in the problem definition. And this model uses the depth first search, according to me, it uses the depth first search, which is an algorithm for traversing the tree of graph structures. And this algorithm starts at the root node and explores as far as possible along each branch before backtracking, and it uses the last in, first out strategy, and hence it is implemented using the stack. So this is implemented using the stack. The DFS, which we call the depth first search, it goes deep and searches till it gets what the user actually wants. And this is how we can use the uninformed search algorithm in the LPP or laptop price predictor. And when I go to the point of AI accountability, first of all, is like the cornerstone of the governance of artificial intelligence. The cornerstone, like the turning point, it is where everything we talk about this accountability. And accountability implies an ethical moral or other expectation, e.g., as set out in the management practices or codes of conduct that guides individuals, organizations, actions, or conduct and allows them to explain the reason for which like decisions and actions were taken. And this AI accountability is so important since it protects the model from intended users, unintended users, like those that shouldn't use the model in another way as what it is supposed to be doing, which would yield into inaccurate or incorrect results. And as I go further with AI accountability, have the application of this AI accountability to this model. The model should always make sure it gives back the right output to the user as a result of the user being prompted to fill in his or her details of the exact laptop. So this model is the model's responsibility to give back to the user what he or she specifically needs at that moment. And in this case, accountability deals with different stages in the AI life cycle, which include the following. We have the design, one of the first steps in the AI accountability, which is articulating the system's objectives and goals. Like for the LPP, objectives is to give back the price estimate of the laptop the user needs. Have development, like defining technical requirements, collecting and processing the data, building the model, and then validating the system, and you have deployment. Deployment is like putting into action what the user of the model wants, and then you have monitoring, like the overview of the model. And I conclude, these are the references I've managed to collect for you. You can visit them and just tap on the links to visit websites to get more information about all I've managed to explain in this time. Thank you very much. I appreciate.